In this question, you are given a box of 2 kg over here that's being pushed up from the bottom of the slope to the top with a constant force of 30 Newton, and it's given that the slope is 22.4 meters. Now, even if this length, the slope, is not given to you, you can actually find it using your Pythagoras theorem, because this is a right angle triangle. So you just basically take 10 square plus 20 square, the whole thing square root, you'll get 22.4. But this is given in the question, and the speed at the bottom of the slope is 1.0 meter per second, and when it's at the top it will be 3.0 meter per second. Now, what makes this question difficult is because there's a change in the KE. Alright, most of the question we do is assuming it's constant speed, there's no change in KE, and the fact that there is friction present, okay, because it's a rough slope. So let's start with part A here, and you're supposed to find the gain in the KE. So the gain in the KE, that will be, is basically the final KE minus the initial KE, and the final is half times the mass, which is 2 kg, times the final speed, which is 3 square minus half times 2 times 1 square. So you will have 9 minus 1, and that will be 8.0 joules. Very straightforward. But one common mistake by students is they basically find the gain in KE as half times mass times the change in the speed, your V2 minus V1, then you square it. This is wrong, because that is not the same unless you write here half times mass times the V2 square minus V1 square. Then that will be similar. So do take note of this and don't make this careless mistake. Next, for part B, you're supposed to find the gain in the gravitational potential store of the box as it moves from the top to the bottom. So for part B, very straightforward, the gain in GPE, okay, which is mgh, the mass is 2, times the gravitational field strength, that's 10, and the height, I will be using the vertical height, which is 10 meters. So the gain in GPE will be 200 joules. Now, of course, as we learned in the class before, this is similar to work done to bring it up vertically, because remember, to bring the box up vertically is the same as to bring it diagonally up, because the height is the same, the weight is the same. So in a way, force times distance, and the force is actually the weight, 20 Newton. Alright, 2W equals to mg, and then the distance here in this case will be the height. Okay, so basically it's like your mg times the height. So basically both are the same. Now the next part, okay, find the work done against frictional force. Of course, many of you will find that work done against frictional force is friction times the distance. But the thing is, you do not know the frictional force. Of course, you know the distance, 22.4. So there's no way to find the friction, work done against friction, unless you're going to use conservation of energy. Now, okay, depends on you. Okay, let me propose this. So it's like the original work that you put into the system is your work done by the pushing force, which is the 30 Newton. That energy that you put into the system all will go to the gain in the GPE and the gain in the KE, and then to the work done against friction. So first of all, if you can understand this, that would be good. If you're able to see this, whatever you put in, a little bit goes to the, because of the gain in height, there's a gain in GPE, and then there's a change in speed, in this case an increase in the speed, so there's a increase in the KE, plus the work done against friction. Of course, this is in a way wasted, because in the form of internal energy, your heat energy. All right. So if you understand this equation, the conservation of energy, then you can safely just put in the value. So first of all, what's the work done by the pushing force 30? There will be force times distance. The force is 30 Newton, a constant 30 Newton, and the distance, always choose the distance that is in the direction of the force. In other words, parallel to the 30 Newton, so that will be your 22.4, and next that will be your GPE, which you have found as 200, plus your gain in the KE, that will be your 8.0, and finally that is what you want to find, the work done against friction. Okay, there's no need for you to open up to friction times distance because I want this as a whole. So if you can just make it the subject, the work done against friction, okay, this simple math, you just minus off and you end up with 464 joules. All right, or of course round off to 2 sig fig, 460 joules. Now let's sidetrack a little bit. What if the question given to you is the box decrease in speed as it goes up from 3 meter per second to 1 meter per second? Now if that's the case, okay, the change is still of magnitude 8 joules, okay, like what you calculated over here, and definitely this equation applies. It's just that this KE here, it has to be minus 8.0. If assuming the height, everything that it goes up is still the same, that means to say the work done, you no need 30 newtons to push the box all the way up to a height of 10 newton. When the speed here decreases to 1, you will have a smaller work done by the pushing force. The pushing force will be smaller. All right. Okay, let's go to the last part where you're supposed to find the acceleration of the box. Now, there are actually two methods of doing this question here. I will choose the easier one, and that's using kinematics here. Let's draw the speed time curve as it moves all the way up. Take note of that. The speed initially is 1. This is your speed, and this is your time axis. And it's a constant acceleration all the way to your speed 3 here. And you know that the area underneath the graph, that will be your 22.4 meters. And what other information do you need? That's the unknown t. I do not know how long it takes. So you have done this in kinematics. You can actually use the equation, the area under the graph, which is 22.4, and that will be area of trapezium, which is half times sum of parallel side 1 plus 3 here, and times the height difference between the two, that's your t. Therefore t will be 11.2 seconds. So last step, if I need to find the acceleration, I'm using v minus u over t. The final speed is 3 minus 1, and the time taken is 11.2 seconds. And that will, I will have an answer of 0.18 meter per second square. So that will be the acceleration. Very straightforward. Next, I will continue to show you the second method, which can be a bit more difficult because you need to resolve the weight into two components that's here and here. You have learned your vector diagram. All right, that is your parallelogram like that. So first thing we need to do, a bit tedious of course, let's find the angle over here. And if you use your math, you know that this is tangent theta is equals to 10 over 20, and you can find your theta, the angle there, to be 26.57. Next, with the angle known, you can find the value of this component of the weight that's in this direction. Why? Because I need to know all the forces that's acting on the box along this direction. There's the friction, that's one. There's a component of the weight, all right, and there's a pushing force, 30 Newton. That's all along this. So this component of the weight that's perpendicular to the slope here, I no need to worry about that. I only need to know this. And to find this component over here, firstly, you have to know that the angle over here, this angle here, will be the same as this angle, 26.57. So if you resolve it, just this is your math, I hope you know. So to find that component, there will be sine 26.57 is equals to your W over 20, and you will get your W, the weight component that's over here, to be 8.94 Newton. So that means to say now I have found the component of the weight that's over here, your W, which is your 8.94 Newton, and you have the pushing force. Let's draw it this direction now. That will be 30 Newton. And now the next thing I need to find is your friction. All right, and how do you find that? Which actually you kind of that you can actually find from what you have in your part C, because the work done against friction, that will be your friction times your distance, and you know that the Work done against friction is 464, and the friction is your unknown, and the distance will be 22.4. That's where you find your friction to be 20.7 Newton. So in other words, this friction is 20.7 Newton. So once we have all the three forces, we are going to find, I'm going to write it over here, a bit no space. All right, so your F net is equals to your MA. And how do you find net force? There are three forces acting on the box here, the 30 Newton, the weight component, and the friction. So I will just take your 30 minus away 20.7 friction and minus the weight component, which is your 8.94, and that will be your mass, which is 2 kg, and times A, the acceleration is what you want to find, and then you will get back the same answer, 0.18 meter per second square. So that's another way of doing, and of course it is definitely so much more difficult. So if you can stick to this. Of course, I've shown you examples where actually sometimes using conservation of energy, or in terms of energy, you can solve it easily. But for this case, the kinematics is so much easier compared to the using energy. Just to add on, just in case some of you ask, why is it that when we are doing this, there's no need for you to find this component of the weight? Because when we find your MGH here, we already taken into account the weight. All right, so there's no need for you to resolve. But for this case, yes, you are going to find all the forces that's acting along this direction. That's why you need to resolve. All right, I hope this you understand this question now. Thank you.